Okay, here we go. Quiet, please. Okay. So this unit is going to be, the first few days are about properties of exponents. Then there's a unit on scientific notation, a lesson on scientific notation, which we don't do a lot with, but we really should know what is scientific notation. And then we're going to do the variations, inverse and direct, which we've already talked about direct variation, but we didn't really do inverse. And that kind of doesn't fit anywhere else, so we'll put it in right here. You know, I would expect, like say, probably every 2 or 3 days we'll have a quiz and a test on the 27th. Actually, we started a day late because yesterday we didn't get anything done, so maybe that ends up being the 28th. But things change. In this class, things change, and we've got the time to deal with it. So understand that everything we've done up to now is linear, right? Linear meaning that, you know, if you graphed it, it's a straight line. Really, linear means that the variables all were raised to the first power. Nonlinear is when you start raising variables to the exponents which are not 1, right? Normally, if you raise something to the first power, you don't even see the exponent, right? I mean, x to the 1 is just x. And so far, everything we've done has been kind of along the lines like that. And both the x and the y's, they had 1 as the exponent. That's why you didn't see it. When you start adding exponents like 2 and 3, okay, then if we graph something like y equals x squared, it's not going to be a straight line anymore. Neither will x to the third. And even the square root of x is actually could be written like x to the 1/2. So it has an exponent, and it's not 1. So it's not going to have a straight line graph. So, I mean, we're not dealing with all of that yet. We are, you know, trying to like learn what are the properties that you use to simplify when you have exponents other than 1. And, you know, there's 7 properties, and I think we take 3 days to go over them. This first day is all about multiplication. Okay. So first to review, right? If you take like 4 squared is 16, right? The 4 is called the base, the thing that's being raised to a power, right? The 2 is the exponent, and actually this whole thing, 4 squared, is called a power. A lot of times we use exponent and power interchangeably, like the same thing, and that's okay. You know, if you said, what's the power of 4, and you said 2, that's okay. I mean, I think the textbook tries to make the distinction that that's not exactly the power, that's the exponent. The whole thing is the power. So I wouldn't worry about that, but power, exponent, base, pretty important to understand that the base of that is the number being raised to a power. Okay. So we know what it means to have an exponent. Like x to the first is x. X squared means x times x, right? It means multiply the base by itself 2 times. X to the third means multiply that base times itself 3 times. Okay? That's not 3x, right? That's x to the third. It's a common mistake to make that, but it's not. 3x is x plus x plus x. Okay. Good. Okay. So here's the first property of exponents, right? You know, if I say x squared times x to the third, like we said on the last slide, that means x times x for x squared and x times x times x for x to the third. How many total times are we multiplying x together? 5 times, right? Which leads us to the property, which is, you know, if you have the same base raised to different exponents, then the way you simplify it is you add the exponents, right? Just like you did over here. 2 plus 3 is 5. M plus n is the new exponent. So for example, 5 to the 6th times 5 to the 3rd would be 5 to the 6 plus 3. Right? So when you're multiplying the same base, add the exponents. Right? If it's not the same base, you can't do it. Okay, so what about that one? 7 to the 3rd times 7 to the 5th. Okay, 7 to the 8th. Now, at this point, we are not also then trying to figure out what that is. We're just trying to use the property of exponents to simplify. I mean, yeah, you could put that in the calculator, do 7 to the 8th and write it out, but we want to make sure we get the concept of adding the exponents. Okay, how about this one? How many 9s are there in that string? There's 11, right? Now we have 3 bases, right? And each one's got its own exponent. The 9, the first one, you don't see it, so you assume it's 1, right? So then you're going to say, this is 9 to the 1 plus 8 plus 2, which is 9 to the 11th. So try those two. First one, 5 to the 10th, right? How about the next one? X to the 9th, right? There's a 1 there. So you add them all up. Okay, here's our next property. Okay, what if you've got a base raised to a power, and then that's in parentheses, and it's raised to the power again? Well, remember, what does it mean when we square something? It means multiply that thing times itself, right? So if I say x squared squared, that's x squared times x squared, right? And now we can use the property from before. What do you do with the exponents? When you're multiplying the same base, you add them up and you get 4. Not a great example because in the end, 2 plus 2 and 2 times 2 is the same thing. Okay, what about this one? X squared to the 3rd. X squared times x squared times x squared. Again, what do you do with the exponents? You add them up. 2 plus 2 plus 2 and you get 6. So, the property is if you have a base in parentheses raised to a power and then outside parentheses you raise that to a different power or exponent, it's a multiply. Right? A to the m to the n is a to the m times n. So, for example, right? Yeah, this is a times. So 3 to the 4th squared would be 3 to the 4 times 2, which is 3 to the 8th. Multiply. Right? So to raise a power to a power, multiply the exponent. Yeah, you multiply these or these or these. Multiply, right? What's that? Okay. Okay, thank you. So again, what's this one? Negative 6 squared to the 5th. Okay, so multiply the exponents. That'll be negative 6 to the 10th. Right, multiply. It's not absolute value. Those are just, yeah, I mean, they're different. Sometimes you have nested parentheses. They use different symbols for the outer one. No. No, what does absolute value look like? Straight, right? Those are not, absolute value would have looked like that, right? Okay, how about this one? What's the base in this one? It's y plus 2, right? It's what's being raised to the power inside that inner parentheses, right? Y plus 2. Okay, so how do you say y plus 2 to the 6th squared? What do I do with the exponent? Multiply the 6 times 2, right? So this is y plus 2 to the 12th. That's it. Yes, absolutely. What's that? On a negative? Around this? The truth is, for this negative 6, because, for example, negative, if I don't have parentheses like negative 6 to the 10th, what that means is 6 to the 10th with a negative in front of it. So it's a negative number. But this here, you're going to take negative 6 to the 10th, and actually that turns into a positive number. So the parentheses make a difference in that case. Okay? So, I mean, in this case of the negative 6, those parentheses are not grouping, right? In the next one, the parentheses are actually grouping symbols. They're combining two terms, y and 2, y plus 2. I mean, it's an important point. Yeah, Connor. No, it's not the same thing. I mean, what does it mean to say y plus 2 to the 12th? Let me jump ahead here for a second because I have it in one slide, not there. Well, I'll show it here. So let's just say, for simplicity, instead of doing y plus 2 to the 12th, what if it was just y plus 2 squared? Right. What does it mean to square something? Multiply it times itself, right? So that is y plus 2 times y plus 2. I mean, that's what it says. Take that base and multiply it times itself. Okay? Now, we're going to get to this, but when you multiply 2 terms times 2 terms, that's the process called FOIL. So I would have to multiply y times y times 2, 2 times y, and 2 times 2. And if I combine like terms, y squared plus 4y plus 4. Okay, if you thought you could have just like distributed that and call it y squared plus 2 squared, right, you would have been missing the 4y. So you don't want to do that. You know, you can't move the parentheses in when you've got more than one term inside the parentheses. I mean, it's kind of a subtle point, but in the end, we make a lot of mistakes with that in every level of class, believe me, every level of class. Okay, let's do these U tries right here. What's the first one? N to the 18, right? Multiply. What's the second one? So the base is m plus 1, and 5 times 4 is 20. And then we're done. You don't have to do anything else with that. Here's the third property that we do today, which is what happens if you have the parentheses, the exponent outside parentheses, and there's more than one factor inside. I mean, in this problem right here, the base is x times y. Okay, you may get confused. Okay, isn't this what I just asked on this other side? No. I mean, on the other side, it was x plus 2. So it's two terms separated with a plus. If I say like 2x and raise it to a power, then you can bring the exponent inside. In fact, that's the property. So like xy to the 4th, we know that means you take the base and you multiply it times itself 4 times. xy times xy times xy times xy. Now how many x's is that? 1, 2, 3, 4. So what property says I can like switch the order and it doesn't change the multiplication? Commutative. Commutative says you could change the order. I mean, honestly, we'd probably use a combination of associative and commutative to make this, but I'm going to move all the x's together and all the y's together. And now, how can you write x being multiplied by itself 4 times? X to the 4th, y to the 4th. So essentially, what did we do with that 4? We moved it inside the parentheses. Yes, if there's no plus or minus inside, you can do it. But not if there's a plus or minus inside. Yeah, then you can do it. I mean, this is a multiplication. So here's the property, right? AB is the base, raised to an exponent outside parentheses. And you could say it's not really the distributive property, but it's okay to say distribute the m. You put it on everything that's inside the parentheses. A to the m, B to the m. So, example, 23 times 17 in parentheses raised to the 5th is 23 to the 5th, 17 to the 5th. Right? It's distributed. Right? But you can't do, that's not the same thing as like 23 plus 17 in parentheses and then bring it inside. That would not work. I mean, you could try it yourself. Right? If you put this in the calculator and then put that in, it's not going to be equal. So that's not a property. Well, this is just kind of showing where the property comes from. Ultimately, what you want to remember is this right here. If you've got a base inside, a base with more than one factor inside parentheses, and it's all being raised to an exponent, then you distribute the exponent. Distribute. And that's the third property that's considered multiplication. So how about this one? 24 times 13 to the 8th. What am I going to do with that 8? What is it going to look like? 24 to the 8th times 13 to the 8th. Okay, try another one. 9xy squared. 12. You're 2/3 right. Yeah, you got to distribute onto everything inside, even the numbers, right? It's got to be 9 squared, x squared, y squared. Right? So distribute to everything inside. Again, it's a common mistake. I'm saying, like, even in the higher classes I teach, pre-calculus, whatever, that they don't deal with the number. They think somehow that the number isn't involved. But you still got to do the arithmetic with the number, even if it's not a properties of exponents thing anymore. Yeah. Is 9 squared 18? 81? That'd be okay. Yeah, in fact, usually that's what you would do. But, you know, we haven't done that with any of the other ones, so I was just going to leave it. And I just did the same thing. Oh, boy. Okay, I get rid of that. 81. Okay, how about these two? What's the difference between these two? Yeah, I mean, if you distribute, you have to distribute onto the negative also, or you could just consider it like -4 squared z squared. And what is -4 squared? Positive 16, right? That's a plus. Negative times negative makes plus, right? But on the second one, because the negative is outside the parentheses, it's not being squared. So that's just -4 squared z squared, which is -16 z squared. So it makes a difference if the negative is included or if the negative is not included. You know, we point it out because it's just a source of common mistakes. Okay, almost done. Good job. Okay. So try those two. So what did you say in the first one? about the second one. So negative 3 squared n squared, but negative 3 squared is positive 9. What do you mean switch to parentheses? No, you don't need it. I put it around the negative 3 again for that same reason. You want to make sure that the negative is part of what's being squared. Okay, I think I got one more slide. Okay, counted wrong. Okay, try that one now. That's going to be a combination of things. In fact, this is actually a me try, not a you try. But so, what's the first thing that I should do? Okay, so I've got it first. First, I need to distribute the 2, right? What's that going to look like? 2 squared, x to the 3rd squared, and I still got this times x to the 4th. Okay, now, how do I simplify x 3rd squared? You multiply, right? When you raise a power to a power, that's the multiply. Well, I can simplify the 2 squared as 4, and now it should be x to the 6th times x to the 4th. Okay, now how do I simplify? Now's where I add, right? So 4x to the 10. Done. So we ended up using all 3 of the properties on that one problem right there. So that's about as hard as it gets. We good? Sean, are you good? Okay.